start to make sure that you formulate several things around those very specific strategies. So if you could envision a very crisp presentation in your mind, because if I'd had a chance to prepare it, you would see a very crisp, I'm sure it would knock your socks off presentation of strategy in the middle of a pentagon. And going around that pentagon would be various things that would link into that strategy. One would be to make sure you have the right people that are helping you to do this work. And that should be a broad-based group of individuals, not individuals that have just one particular type of discipline or field of study that they've come to the table with, because birds of a feather always think alike, and you need that diversity of thought when you're putting together, thinking about the strategy and objectives that you're trying to achieve, and then the measurement standards that you're going to use to link into that. Make sure that the folks have the right training. And when I talk about the broad-based group of thinking, because you are all regulators, I would encourage you as much as possible to engage your industry to understand the things that they are currently doing, the things that they're currently working on, new concepts, new technologies that they may be introducing into their fields, because this could dramatically affect how you're going to measure risk and how you're going to think about risk. And that needs to be a continual process. I've worked with one government agency who they tried to do this, they went out, they had conversations, but they never refreshed those conversations with their vendors and with those that they were regulating. And so very quickly they sort of were in a bad place with trying to measure risk with the entities that they were trying to regulate, because the industries they were regulating had moved on, and their technologies had changed, and they had moved on and they were somewhere else. The other reason why I would encourage you to engage those that you're working with and regulating is because there may be a lot of information that they have readily available, or that is unique and cross-cutting across industry, that could be leverageable to help reduce costs. I'm sure you all have heard it, but any time that new regulations are enacted, there is a financial cost that those you're regulating have to bear to come up with that new information. So to the extent that you can leverage information that they already have available, that's a great thing. To the extent that you can come up with something and help them understand how them providing this information to you all is going to also benefit them financially, that's a great thing as well. These organizations typically have some type of bottom line that they're managing to, and if you can convince them that by providing this information it might actually help them to potentially develop a new product or to head off a risk that would cause their stock to plummet if they were to take a hit on a particular issue, that might get their attention, and they might be more willing to then invest in providing that information. Continuing around, the next thing was organizational design, just making sure that you have the right buy-in from those that lead your organization to support the effort that you're undertaking, and then putting the right governance channels in place and governance structure in place to then effectively manage the strategy and the risk and the objectives that you're trying to get to. Making sure that you have the right processes in place. Like I said, I never saw a control I didn't like. So you want to make sure, obviously, that the data you're receiving in, the data that you're then going to use to complete your risk assessments is complete, that it's accurate, that it's consistent, that it's reliable. And if you don't have the right controls in place, then you won't be able to achieve those objectives. To the extent that you can get a single source of information, obviously that's going to be better than trying to piece together and cobble together a patchwork or a funky quilt of information that maybe is inconsistent or is not reliable. Sort of continuing around, then you'd want to make sure that you have the data that is coming in is actually the right data that you set out to obtain, and that that data is going to link back to the strategy and objectives that you set. And then finally, the technology platform, making sure that you've thought through the different nuances of the technology platform. Again, it's a very simplistic model, and I wish I could have something really cool to show you. The one other thing that I would leave you with, and it's not a great epiphany, but it's something that I thought about while I was trying to rush to get prepared for this, and it was actually something that I saw a CFO mention probably 15 years ago during a discussion. And maybe he was on the very leading edge of this whole data management, and using data to manage risk, using data to develop new products for his clients. But he basically broke it down into 4 points. You've got to collect the data, you have to have the mechanisms to collect the data. You have to be able to know that you can rely on that data, because then once you have that data, then you can start to accumulate it, and it provides you with information. And that information, if used and interpreted wisely by the individuals that you have on your panel that have a very broad background, can start to use that information to make knowledge, to accumulate knowledge and make knowledgeable information and informed decisions, which hopefully will lead to some wisdom, which would allow you to avert some type of risk issue with those that you're regulating. And so with that, I will mercifully cede the floor.
Thank you very much, Walt. Then to end this session's introduction, it's Dr. Erik Loewen from the GE Hitachi Nuclear Energy.
Pretty close.
Pretty close?
Pretty
okay.
close.
The floor is yours.
Okay, thank you. Good afternoon. What I want to communicate to you is how to tune a safety culture with regulations. How to tune a safety culture with regulation. A lot of people don't realize in my industry that my first job with a big company was in the oil and gas sector. I was an undergraduate studying chemistry and was fortunate enough to get a summer intern job at a company called Rio Blanco Oil Shale Company in Rifle, Colorado. It was a joint venture between Mobil and Gulf, and what we were doing technically was in situ retorting underground. So it was a mixture of mining and oil all in one. And I showed up onto this job site having no idea what a safety culture was, but I felt it. I felt it from above. I felt it from my peers. They worried about if my hard hat fit right. They worried if I had my glasses on. They worried what kind of shoes I wore. They told me about the hazards of hydrogen sulfide. They taught me about olfactory fatigue. They taught me how to climb ladders and descend stairs. It was good. Because my previous jobs as a carpenter helper, as a farm laborer, as a lumberjack assistant, if you will, were safe, but it didn't have a safety culture. I finished college with my chemistry degree, somehow heard a calling to the sea, living in Colorado, and I joined the Nuclear Navy program, and I've been in that industry ever since. So I want to share some of our safety culture with you today. One of the tools that we have that we use that got developed is this thing called Probabilistic Risk Assessment, or PRA, that David talked about. If you go to the UK, they call it PSA, Probabilistic Safety Analysis, but it's the same thing. If you get the Sapphire code, you're good to go. Okay? The Brits had to name it something different. And I want to share kind of the origins of how that tool came about. So in 1957, this new technology called nuclear power was trying to site plants, and we were going to site very close to customers. So why not put it in a city? If you've ever been on Long Island, or not Long Island, Manhattan, you can see a coal plant right next to the UN building. So the industry said, well, could we site them? So they looked at a very crude probabilistic assessment, assumed some worst case things, not necessarily reality, and if you had core damage and your containment release radioactivity, thousands of people would die. More work needed to be done based on that analysis. So we went through the 50s and we got to the 60s and we looked at what the aerospace industry was doing, and they had this thing called fault trees, and then we added to that event trees. So let's say that instead of talking to you about safety, you asked me to come give you a concert with my ukulele, okay? And I would do that concert. If we looked at what could cause me not to do that, it would be a fault tree. This is a human-made object. Engineers are involved. Marketing cuts corners. Sales steals some of the money, right? Production forces people to go faster. So one thing that could fail is one of these strings fail. So what we could do is put more strings in my backpack. We could make strings with that are stronger, so we prevent that fault from occurring. But couple that to an event, and I don't mean to disparage Alice in your lunch, but let's say that I got food poisoning at lunch. So that event, it was a wonderful lunch. That event plus a bad string would prevent me from doing a concert. So those are the tools that we developed. So they came to fruition in 1975 with a professor named Norman Rasmussen at MIT, and he developed this report that he simply named the Reactor Safety Study. And in there they put these fault trees and event trees together and came up with these sequence of events that could lead to an event. And he defined them very specifically. One was core damage, and the other one is, could you release from your containment? The report was hailed by some and criticized by others that there was too much uncertainty. How do you know if it's going to work? So we went through the 70s and we got into the 80s. And then the Nuclear Regulatory Commission started adopting this tool and looking at it. And they published a report that's, the title's up on the page, in 1990, where they looked at 5 nuclear power plants in the United States. So they came up with a metric and they said, we do not want to have core damage in 0.00001 or 10 to the minus fourth or 1 in 10,000. That was their goal. So when you look at these 5 technologies or these 5 real plants, the probability of core damage was about 1 times 10 to the minus 6 or 1 in a million, a low probability event, but not as low as me winning the lottery ticket on the Powerball, okay? And they use this report to look. Now, if you read the report, which I've done, it's about this thick. If you look at all the appendices, if you had core damage and containment release, depending on the plant and the site, the death was estimated was between 1 and 1,000, depending on which technology and which plant. So how is that relevant? So the next is a black swan event. Fukushima. Okay? That event occurred and we had all these tools, and 2 of the technologies that were evaluated in that 1990 report are very similar to the technologies of the reactor systems that were at Fukushima. So here we had that coupling of a man-made device with this thing called Earth that happens to be unstable. Okay? So to understand what happens, I want to share with you 3 numbers, 3.1, 5.7, and 14. Okay? When that site was chosen in 1960 to build it, the country of Japan was fully aware of earthquake hazards and tsunamis. They were an island nation. And so they sought what was a tsunami hazard at the Fukushima site. They consulted world experts, the regulatory body, and they said that number is 3.1. So the engineers built the site at 10 meters, a factor of 3 in safety. Because humans like you go to events like this where you gain knowledge, the same thing occurred here. During the 90s, they identified that the tsunami hazard was really 5.7. The site adjusted their intakes and their pumps to be above that 5.7 meters. Okay? So what happened on 3/11? The tsunami wave of 14 meters hit the site. 14 meters. What people sometimes don't understand, it was a confluence of the underground topology there that caused 2 waves to add together right in front of the Fukushima site that gave this 14. The death toll of the 15,000 people, the 2,500 that are still missing, predominantly was because of a 5.7 meter wave, not this 14 meter wave. Okay? So you as an industry, as you choose to continue to use this probabilistic risk tool, I would caution you to make sure you have that right coupling with that external event, that island of instability called Earth, and those events that occur to that man-made system, and you know how those work. Because it can inform you where, if you have $100 in your pocket, where to spend that money, but we also have to use that tool wisely. Also, I would give you a word of caution. If you look at the refinery part of your industry, you're dealing with some systems that are nonlinear, where you're doing distillation, you have pHs and stuff. So for us, when you do a probabilistic risk assessment, is whether the valve opened, the pump turned on, this worked. When you're doing something that are nonlinear, that's where you need to be cautious on how to use that. So where do we go forward? So because of that, I would say stick to those things that we know work, your HAZOPs, your failure modes analysis, and the thing called safety culture. Because you have humans that are out there on the deck plates that are doing this kind of work. And what a lot of people don't realize is the Nuclear Regulatory Commission did not start embracing a safety culture, did not acknowledge formally a safety culture until 2011, where they issued a Federal Register, we want to have a positive safety culture. It wasn't until 2014 where they came out with common knowledge of what, or language that should be used in that safety culture. If I could distill it down to 3 things, it's this. First thing you got to do is identify problems. If you do that, second thing you have to do is learn from them. And the third thing is you need to have respect within the organization so that the deck plates are heard along with the regulatory body. So how do we tune a safety culture? So many of you in this room, if we take this metaphor of this ukulele again, are way up here. You're the regulators and you tune. So you could go back to your country, add a new regulation, and hit the string and hope that body politic, those deck plates hear you. But we know in each organization we can have sounds that are muffled because of your own organization, or we can have management of those contractors or subcontractors that were prevented. So I give you one metaphor. It should be like this. Maria. Maria, you're not paying attention to me. Maria and I met. That's my table. So I would challenge you to have a safety culture like this, where you're at the bottom and where the body, the deck plates, can share and communicate to you. So they can say, here's where we see what's going on. So no worker goes to work and says, today is the day I'm going to smash my thumb. Today's the day I'm going to lose an arm. Today's the day I'm going to die. So listen to them so that you can tune your safety culture. So I have one wish, and that wish is that this energy sector, oil and gas, and the nuclear industry continue a strong safety culture, because with abundant, affordable, clean energy, we can solve the world's problems. Ann?
Thank you. Thank you very much.